back. This is how the project is going to spoil. Let me show you go near that. So you have your delay, and then you have return right. Is it running or spoil already? Take some time. So you have your program here. So before you return, you need to make sure that you load back the value of working register. So here's the part where you need to pop up. Try to show the instruction that's coming. Sorry. This push R, that means if you want to save any values, the push R should always come before calling the subroutine. Okay, now the pop R, this pop R should be always whereas this pop R should be always before return. So sorry, I'm just writing a bit off. So what you should pop R, you should pop R working register. So pop R working register means you're calling the macro, right? You're invoking this macro. This is actually working register, working register, working register. This is also fixed. So as mentioned, move FF post decrement 1 to working register. This is actually currently FSR1 is pointing at this address E01. Now here I do not know what is the value, but you are moving this content. I mean this is just a dummy thing. The first line is actually a dummy instruction. This one. This one is just a dummy instruction. Actually what we want is we just want to decrease the FSR1. So we're going to move FF, the content of FSR1 currently is pointing at E01 to working register, which is not the right one. And then you post decrement. What happens to this one? It will decrease by 1, right? Come back here. And then what do you do? Move FF, INDF 1 to working register. So this is the actual content of working register. Now you load back into working register. And then you return. When you return, when you come back here to clear F, is the content of working register same as before you left? Yes. So it will be as if nothing happened to the working register. Get it? So that is the push and also pop R. Now take note that if you have more things to save, you need to push here as well. Now let's say, okay, assuming that, okay, so far you have any question before I add another example? Yes.
After the dummy value, the dummy address.
First FSR is pointing up here, right? Pop R, you see there's 2 lines in pop R. The first one is you move the content pointed by FSR1 to working register, which is here. I do not know what is here, but whatever here will be loaded into working register. After you load that, you decrease by 1, right? Post decrement. So your pointer will come here. And then what's the next line? Move the FSR1 to working register. So this is actual content of working register, be loaded again. So 2 times 2 values will be loaded, but the first value loaded is not the actual value. The first instruction is just to decrease the pointer only, that's the aim. You understand? So these two macros are the same. Is there any other question? Now let's say in the subroutine you are using, for example, a different bank, and in the main program you are using a different bank. So definitely before you call the subroutine you want to make sure that you save the bank. Assuming, like in this case we are not doing that. I just want to show what happens if you push more than one and you pop more than one. I just want to show that. So let's say in the main program you are using one bank and you call the subroutine is using another bank. So definitely if the main program using another bank and then you call the subroutine, it will change the bank. When it comes back, it will be the subroutine's bank, not the main program's bank. So in this case we need to save the bank value, right? So how can we save the bank value? How to save the bank value? Push R what? Push R what? Push R what?
You need to add the original.
What's that?
Original.
No, assume they have already done. Now I'm just telling if you want to save the bank content, what you need to push? Huh? What is the address? The bank. Which register actually defines the bank? E. Bank. Yes. And you use the instruction move LB, right? What is the B? Huh? I know, what is the B? Yes, BSR. Bank select register. That is the register that you should save. Do you understand? Because that holds the value of the current bank which is active. So you need to push R, BSR, bank select register. You understand? So in this case, let's say you push R working register, you push R, BSR. So here, first what happens, you push the value of working register, and what happens to the pointer? It increases by 1. And then you push R, BSR again. So the content of BSR is here, and what happens to the pointer? It increases like this. Then you call the subroutine. And then when you come to the subroutine, okay, do whatever, blah, 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 maybe using different bank or whatever. Return one, which one you should pop first? Yes, you should pop BSR first. Always remember, the last in should be the first one out. So if you push R, BSR the last, you should pop R, BSR first. So you should pop R, BSR. If you do the other way around, what do you think will happen? The BSR value will go inside working register value will go inside BSR. So remember, the last in should be the one first out. So BSR is the last thing which you push inside. So that should be the first thing that you pop. So now, according to the pop, what happens? It will take this value, first pop R BSR, right? It will take this value, it will load inside BSR, and then it will decrease the pointer. Come here, and then INDF, this one, will load back into BSR. So this is the actual value is loaded back. Is it okay? Then you pop R working register. Earlier it was the BSR value. It's actually loaded back into working register. And then you decrease by 1. This one. So this is the actual value of working register. It will be loaded back into working register. So this is also used. So the BSR gets back its original value. Working register gets back its original value. Then you return When you come back to the main program, the BSR and the working register is as good as before you call the subroutine. Can you understand?
Yes.
Relatively, I think it's an easy thing. So, if you want to use the push R and pop R, you should declare them like the duplicate operation. You should also declare them before the program starts employed. Is that okay? Okay, okay. Now,
Just curious to ask about the push BSI. That means you have to write another micro for push BSI.
no, this is the standard macro. That is macro receives the argument. So whenever you call the macro and tell what's the argument. Working register. This one push R BSR. Of course, you see there's another push there. This macro is used to store value. This two macro is used to store the content of file register. So we are not using this for now. So we have to push R and pop R. Is that okay? Any other question? Now, one last thing before. Now this call function comes with option comma S. It only comes with the call function. The S bit, call and comma S. So the S is actually fast. There is another register which is known as the fast register stack. This stack is actually 3-layer deep. 3-layer deep means you can only store 3 levels of value. And what does the stack do is, it allows the PIC to save working register, status and BSR in the fast register stack. So how do you actually use this fast register stack? So assuming that we are doing this one right, can I make changes with this? So by using fast register stack, I don't need to use this push R. So what can I do is I call the subroutine name, then I put comma fast. When I do fast, it doesn't happen fast. It's the same speed only. But what happens is, fast is actually a stack. It's a 3-layer stack. So what does the fast register stack do? It stores the value of working register, BSR and also status. These 3 special function registers value are automatically saved. So when you call this subroutine, I also don't need to do this pop thing. So when I return fast. So means, assuming the same example, I need to save the working register and BSR. So what I can do is, I just call subroutine and just use fast. What happens is, before going there, automatically the values of working register, status and also BSR is saved in this fast register. That's why it's 3-layered up, because you can only store the values of 3 file registers. And then you're free to do whatever you want. Return fast. Return fast means automatically the content of working register, BSR and status will be restored back. So when you come back here, the status, the BSR and the working register will be as same as before you left. Do you understand? And this fast can only be used with call. Our call doesn't have this option. Only call have this option. So in other words, just to wrap it up, if you have a subroutine which requires you to save a certain file register, how you know? Because you see the same file register you're using here and subroutine also you're using. So most likely the data will be overwritten with whatever that you're using subroutine. So if you have that case, that means you need to save the value of the file register first before you call the subroutine. Now most of the time, the most crucial file register that you need to save would be BSR, status or working register. So what they have done is they have made it easier for you by creating this fast register stack. So when you're using this fast register stack, you don't need to push pop on. You don't need to put that. You don't need to initialize this one. This one also not required. Nothing. It is automatically it will load. This is a dedicated 3-layer stack. So automatically BSR, status, and also working register will be saved. And when you return, it must be returned fast. So you don't write this value. Now what if besides these 3, if you have any other special function register besides these 3 that you need to save, then you need to use push R and pop R. If you're using push R and pop R, then you need to do this and you need to include the macro. Is that okay? I've already outlined, segmented for you already. The only thing is now you have to understand and practice. So tomorrow tutorial we will also continue with class. We'll do one example and we have time, then we'll see all of you make the coding for that program for subroutine. So with tomorrow's one, that will be end of chapter 4. Actually, there is more to this. Chapter 4 there is on stack frame and things like that. Stack frame is one of the most hardest thing to understand. So because it's not very popularly, it's a very useful thing later on, but we don't have the luxury of time. And if you see that portion, most of you will end up crying. Because in the whole microprocessor thing, the stack part is not this one, this is, I've made it easy for you. There is another one which is known as the stack frame and things like that. You're going to store using stack and you're going to retrieve using stack. So it's not difficult, but for you, you will find it very the most difficult thing for you to understand. So we won't go through that. Whatever stack that we are doing now, I think this is more or less sufficient for you. Understand the concept of stack. How do you do? How do we use it? When do we actually use it? Okay? So I'm going to take attendance now. So for those who couldn't make it for my class, even though if you miss one class, you won't make it for your class. Can you stop recording? No, it's not intimidation.